Mm, okay, so hello. So today we're gonna continue to the chapter 11, like a time series. So yeah, time series data is a quite kind of a quite unique and then a special kind of a data structure because definitely it contains time. So in this chapter we're gonna look at the how Python handle these kind of a time series data set and then what kind of functions or command in Python, like using particularly using pandas, what kind of functions we can use to manipulating and processing the time series data set. So here actually at the beginning of the chapter 11, it briefly summarize about the some characteristic of the time series data sets. So time series data set is defined as a kind of a data set usually recorded repeatedly at a specific point of time. But sometimes, as you can see here, because that means it's a kind of a fixed frequency. So that means like a time series data for every month or every week or every day or every 1 hour, 2 hour, or every 30 minutes. So that means we actually have most of not all of them, but most of the time series data set has some of the fixed frequency, like we recording or observe the data set uh every specific interval. Okay. And then sometimes we can also have a irregular time series. That means we don't have any fixed frequency, which we can also deal with this kind of a data set as a time series data set. So times means a specific instant in time. That's the how what it is about. So there is some definitions about the time series data set. So timestamp is a specific instant in time. And then a fixed period is a kind of a maybe every month or every year kind of thing. And then the interval of time is those kind of uh, intervals, like every month or every time. The fixed periods is just kind of a specific date. And then the experiment and the elapsed time is a kind of a relative to the start time. Maybe we can actually have a some specific time measures. So that means maybe if we can define some specific date and time as a time zero, and then maybe we can we can define the every week after, that's the time one, and then a time two, and then a time three, etc. So this one is what is called the experiment and the elapsed time. So that means we actually define some particular start time as a kind of a start study period. That's what it called. And then we also can be specified the end study period. And then, but in relative to this kind of a starting time, we can actually define some kind of some constant interval, and then we can actually define, okay, here is this time point is the time one, and this time point is time two, time series, etc. Okay, these can be actually very useful when you try to simplify your timestamps, and then maybe you can also define your own time stamp and then a time interval. And then some of the elapsed time is more simplified rather than using the date, it's some specific date. Okay. So now we can talk about how we can what kind of a data types, time series data type and tools we can use. So Python library actually include some of the date and time data, some special way of dealing with this kind of data set, like a calendar related date and time. So there is actually some of the package called the datetime as a basic library package, and then we can importing that some of the functions. And then when we click the datetime.now, this method gonna be give us to the current time, current date and time and second. Okay, so in this case, it's the April 12th, 2023. And then it's this one is hour and minute, and then second, and then this one is the microsecond kind of thing. Okay, so we can also specify the year, month, and day by using the this now function. Okay, it's a simple. And also we can also calculating about the some of the time changes, like temporal changes, temporal differences by using the this minus, or it's like a arithmetically kind of a calculation. So we can actually think about the date time for the this date, and then 2008 June 24th, and then by using the this minus one, maybe we can have days, the difference between those two dates, and then a second, and then we can only extract the days or second. Okay. And then also instead of the using the that some of the mathematical operator, we can also use the time delta function as to calculating the temporal differences. So we can also import into this time delta functions. And then if we have a start date time like this, and then time delta gonna be the by default is the day. Okay. So what does that mean is okay, from the start date, what is the date of the date time after the 12 days? So that means 7 plus 12 gonna be the January 19th, 2011. Okay. Also, we can use the kind of these things like some of the very basic calculations. So this one is minus 24 days, right? And then minus means it's kind of a backward, like what is the date of the date and time 24 days before the start date. That's what this December 14th is about. Okay, so this kind of is a kind of very simple calculation about the uh calculation of the date and time. Okay, and also when you can see it in here at the bottom, like a table, you can see those useful function like a date and time, and then we just see the date time and then time zone informations, what kind of time zone information you are at right now when you're calculating the date and time, what's the time zone you're actually referring to. And then the next one is how we can try to convert the string and date time. It is also the same process when you're using the R. Actually, in the tidyverse in R, there is the tidyverse packages, right? Under these tidyverse packages, there is a lot of functions R functions that handles with the date and time. Okay, in R. In Python, we also have some of the function to the converting to the string to the date time. Like a tidyverse in R. So as you can see here, this is the date time kind of a format. And then as you can see, if you use this str function, that actually converting this date time format into the string. And after that, you can also do the same thing like a string str f time, and then you can designating about the sum of the date time format. Based on this date and time format, this function actually converting to the string function, string into the date time format. Okay.
I know it's clear. It's clear. Hello? Hello?
Okay. Yeah.
Oh, okay.
Okay.
Yeah.
Yeah. Okay. So as you can see the table in the bottom, so you can see that there is a lot of function about the how you can formatting the date and time, specifying the date and time format, right? So
Yeah,
like
just to add something, I think the default time for the
mhm,
date time function is it's like midnight, 12 midnight.
yeah, yeah, right.
Yeah, if I get it right, yeah.
So yeah, and also these are the function that you can customizing about your date and time, and then in R also has the very similar and same function. I think that most of these specification is the follow the very standardized kind of a
Yeah,
formatting
yeah,
function.
especially
So
the
in R,
Y, yeah, the year, the
in
month,
R
the
also
day.
has the same,
Yeah,
same specification. So
sure,
you can just feel free to look at these things, and then you can also using these kind of formatting specification in R. Okay.
sure.
All right, and then the next one is kind of a pretty the same thing, like or also the same example about this kind of a string value, and then we can try to converting this value based on these functions. And then if we have a multiple strings, that means by using this kind of for loop, we can actually converting this one as a date and time function based on this format. Okay. Yeah. And also the same thing in here at the bottom. We can also try to do this. For example, if we have this kind of a string, by using the pandas to date time function, it also has the same function like a strp time functions in the previous example. Okay. And also in this example actually shows about if there is an or any like a none, that means it's not a time stamp. So NAT not a time is the kind of a null value for the timestamp data. So even if we don't have any kind of a timestamp information, in that case, we can just try to leave it as a none or null value for that time set. Okay, like a NAT in this case, right? And at the bottom, it is also kind of
So
a
the freq
function to
the frequency, like the freq equals to none, it specifies that it has no specific frequency, right?
yeah. So in here, if you using this NONE like a none kind of
Mhm.
a designation, that means you have a null value of the timestamp in here, NAT. Okay, that means it is another time. So that means that there is a missing timestamp. Okay, so we don't know exactly what date and time is about for that specific data or value. Okay. Hmm. And then now next section is talking about the very basics about the time series. So as you can see here, the basic kind of the time series object in pandas is kind of a series, you know. So we can just using this timestamp as a series, and then representing about this date and time object like this. This is a kind of a series, like a pandas series kind of a format, like just kind of a vector kind of a data set. And then you can using this date as an index, and then After that, you can define the sum of the assign to the sum of the specific value as a series. So all of these things is kind of an index label. Okay, and then all these are the value corresponding to the each time index labels. Okay, that's how it works. And then if you like a same thing about the pandas series, you can also identifying this date time index by using the dot index function. And then also the same arithmetic calculation used in pandas series. You can actually do the same thing right here, right? And then also you can store the timestamp as a kind of a date time 64 data type, which is the sum of the specific time set of the way of the formatting our date and time. And then you can see here, like a stamp with the index 0 means you can actually extract some specific timestamp right here.
Yeah, sorry,
if you
just
need to.
there's a comment on the data type. It's like date time 64. It's like in this example is giving us in like the NS, if I get it right, is the nanosecond.
Yeah, right.
Yeah, so it's like the most
It
like
is a kind of a very specific and then a very detailed moment of the time.
So I don't know. I don't know
Nanosecond
whether
is
this could be done in R. I'm not sure of that. That R could give this
maybe
precision
I
in
think
timing.
that maybe I think that this kind of a nanosecond kind of a resolution can be used about some of the very natural science kind of experiments, like a physics, like a physics kind of things. Yeah. So, but in case of the social science kind of thing, we don't
We don't need this.
using these kind of a nanosecond kind of
No,
information, but some of the highly experimental situation,
they
like
might need this details.
some
Yeah, they might need
experiment
this.
like a physics, like a physics or some chemistry, like a chemistry or mechanical kind of engineering. They sometimes do some experiment and then store the data is a very detailed resolution kind of data. So because their nanosecond or microsecond is actually for them, microsecond is a kind of a very big number. You know?
Oh, that's interesting.
Yeah. So, but for me, like as a social data scientist like me, we usually kind of observe every kind of a social kind of phenomenon changes or social changes or some dynamics maybe change too quickly, doesn't change quickly. So we usually measuring our time series like hourly or daily. Some hourly and daily is quite rare, but usually kind of
Monthly,
a
quarterly.
daily, maybe weekly or monthly.
Yeah, also quarterly.
Yeah, sometimes even quarterly and by
Annually.
annually, or annually kind of thing. Yeah, some kind of very macro level kind of a big times changes.
Yeah,
Right?
sure.
Yeah. So in the next one is the kind of indexing and selecting and the subsetting. It is also the very same thing. So like a pandas actually deal with this kind of a time series data set and then this time series like a series or data frame in pandas. So it is same thing gonna be applied. So as you can see here, we can we can specify some specific index value as a stamp, right? And then also kind of we can using some specific date as a row index, and then that actually give us about the depth its corresponding value like this. And then even if we have this kind of a long kind of a data set, maybe if we just kind of designating only year, it actually give us about all the year observation outcome, like a subsetting the data by year, right? And then also specify some date, some month or date like this, or some of the specifying the date, and then after this one is actually try to give us to the information after the January 7th, 2011, including the that date, okay, here. And then after that, we can get this kind of information. And then we can also specify some of the temporal range to extract our time series data set. Okay? Yeah. So these are the kind of a very simple, very basic, and then it is very straightforward and then easy to understand. We already learned a lot about how Python, especially for the pandas handles the data set in their
Yeah,
series and their data frames. So it is also pretty the same thing when we looking at, even if when we have a time series data set like here. Okay. And then we can also call the truncate function, like a truncate means maybe if we have some of the longer time series data set, we can just kind of slicing our data set and then get the data set after the January 9th, 2011 one. Okay. So that's the kind of how it looked like a truncate here. Okay. And then also we can try to do the range things for the 2011, and then the period is 100 days. And then every week of the Wednesdays. And then when we try to do this one and then indexing the date, and then set up the Colorado and Texas and New York and Ohio is as a column name. And then we can also do the same indexing and subsetting techniques for these kind of time series data set. And then we can, in here, it says about the extract our time series data set only for May 2001 for all of these Colorado, Texas, and New York, Ohio data set. Okay. And then time series with the duplicate indices in here, you can say is if we have this kind of duplicated kind of a time series data set, in this case, January 2nd is the duplicated. And then we can say about its unique function is definitely false. And then if we have this kind of duplicated, when we try to indexing the data set, we have a multiple kind of observation outcome, right? And then what we can do is for this kind of a duplicate data set is try to using the group by function that we studied in the previous chapter. And then the pass to this one is the level 0. So level 0 means this is the level 0 row index, right? And then we can just aggregate by this index time series, index time, this kind of a date time index, and then we can aggregate them by the mean or count, etc. Okay, or maybe median kind of things. So just try to aggregate into the one single observations, even if we have a multiple observed outcome. That's the way we can actually summarize or aggregate our data set in case even if we have we have the data set with the date and time. Okay. So any questions so far?
No, I think it's clear. I think most of the methods it's calling, we've seen it in the previous chapters. So it's
Okay. Yeah,
yeah, it's
because
fine.
the only difference about the previous what we have done in the previous chapters is this one is just kind of shows the function about the when we had the data set with the date and time. Okay. So in here is also the same thing. Like if we have sorry for that. If we have this kind of a time series data set, okay, and then the sample means we can try to resampling our data set based on the daily frequencies. This is how we can do. And then in here first thing we actually talk about is how we can try to generating the some of the date ranges in the some particular frequency. In this case, pandas date range generating the daily timestamp. And then if we only pass about the start and end date, so that means this one is the start, this one is the end date, right? So by default, we can actually have a daily frequency. That's the reason why we have April 1st, April 2nd, April 3rd, etc. All right, because the frequency is the daily. And if we can designate about the period, that means if we have a start date like April 1st, 2012, we can actually have every 20 daytime kind of observation. So this one is the start date, and then a period 20 is we have a 20 timestamp in this case. That's what period is about.
Yeah, and it's
Okay.
interesting because it
If we
includes the okay, sorry, go on.
it includes
Yeah,
the start date
I wanted
right
to say
here.
that. Includes the
Yeah,
start
and
and
also the same thing. If we have an end date in here, end date including that end date, we can have the 20 timestamp before the date June 1st. Okay, that's how we can generating the sum of the date range with some specific frequencies by using the period function. Okay. And also there is another function called, or maybe if we have a last business day of each month, we can actually have a BM for the frequency option. So whenever we have this kind of a business month kind of a function, it actually shows about the last business day of the month, business day of each month. So in this case, it's the 31st and then the 29th. And then maybe in the April is the 28th, because 29th and 30th and 31st is a kind of a holidays or weekend. So only including the last business day of each month. Okay, that is also kind of a very useful about if we are interested in some specific day of the month, and then it is very hard to define those kind of date time things. That kind of a function actually help us about some specifying those dates, like a BM or MS is the month begin, Okay, first the calendar day of the each month, and then business month begin kind of things. These are the kind of a very useful function when it is very hard to specify about some specific date for our research interest. Okay, there is a lot of function about related to this kind of frequency definition in the table 11.4. So you can feel free to look at it and then maybe get used to it if you have a lot of chance to handle these kind of time series data set. Okay. And then pandas and date range default is the kind of if we have this start, and then a period is we have a 5 timestamp, and then even if we actually have this hourly kind of a definition, same hour gonna be fixed for the each date extract from the function. Okay, and then also we can try to do the normalize this timestamp without any kind of this timestamp, only looking at this date. And then next one is the frequency and then a data offset, which means we can try to do the extract the data set every 4 hours in this example. So we can try to do the January 1st midnight, and then 4 a.m., 8 a.m., and then 12 p.m., etc. We can keep doing these things by generating the daytime timestamp for the every 4 hours as a frequencies rather than the date and time, the days or a month. We can also even designate about the hours and minutes or even second or nanosecond, etc. Okay. Same thing for the even if we have a 1 hour and 30 minutes kind of frequencies, we can actually define these kind of a string function for the date range, and then that actually shows us about the generating about the timestamp or index for the every 1 hour and half, 1 hour and half, 1.5 hour. I mean, also the same option for the month, and then last business day of the month, etc. And then a week of the month date is a very interesting, like a WOM means if we have a WOM third Friday, that means from January 1st and then September 1st, between these time, start and end time, we only extract the timestamp every third week of the Friday of each month. Okay. So that means the third Friday of each month. Okay. So every third Friday of each month, that date gonna be generated as a timestamp by using this WOM and 3 Friday function. Okay. And then the shifting and the lagging means we can actually shifting the some of the specific time series value by using the shifting things like a shift 2 means these two value gonna be moved down to the next two timestamp like here. So these first two value gonna be assigned to this value gonna be this third one, and then this one gonna be the fourth one. Okay, that's
This
the
is
how.
interesting. I
Yeah,
mean, this is interesting
that's
because
the how shifting. Yeah,
it doesn't move with the index. So I don't know how useful it
yeah,
might be.
yeah. It doesn't move to the index. Index is
Yeah,
just kind of a stay still,
yeah,
but
index to
the
but the
value
value,
itself
yeah,
gonna be moved as a
yeah.
lagged or shifting values.
Mm.
Okay. Also, same thing about the -2 means is the backwards. So these two value going up
Yeah,
to the first
I was just
two,
thinking,
right?
I'm not sure if this might be very useful because, you know, you always want your values to be aligned with the index. But
Mhm.
yeah, if you are shifting the
Yeah.
value and giving it a different index, I don't know in what sense of an analysis it might be useful, you know.
So authors
Just a
actually
comment.
suggest about the suggesting about the how we can using this shift function. Like if we can try to computing the consecutive percentage changes in a time series, like like in here like a 2000 plus the 31 is negative 0.117, and then a 2029 is the negative 0.517. In this case, if we can using this one, we can actually calculating about the percentage change between these two time periods. That's the how we can using the shift function. And then we can keep calculating about the percentage change of the each time interval over time by using this shift function.
This is okay.
Because we actually take the next value and previous value, and the previous value divided by the next value, and then the -1 gonna be the percentage change, right? So that's the how we can using for this kind of a shift function.
Yeah, makes sense.
Okay, yeah, and then also we can passing this shift to the some of the frequency of the daily function, or some every every 90t means 1 hour 1 hour and 30 minutes, like a 1:30 a.m. every 1:30 a.m., and then we can actually shifting those things based on the some of the frequencies, like some flexibility about the frequencies gonna be passed if we have these kind of frequency functions. Okay.
The first
All
example
right.
will be on a daily frequency.
Yeah.
The you know, the second one, daily.
Mm-hmm.
And then the
And
the
yeah.
90T is like 1 hour 30 minutes frequency.
Mm-hmm.
Yeah.
Yeah. It's a 90 minutes
Yeah. Yeah.
kind of a function. So that means it's the 1:30 a.m. for the each observation, like a frequency.
Yeah, nice.
Okay. Yeah. Because in compared to the R, actually Python actually providing the some seems to providing the quite range of the good date and time management or manipulation functions.
Yeah,
And
manipulations,
then
yeah.
I think that there is also kind of options in R too, but for me, I didn't have much chances to processing these kind of a time series data sets. So maybe I'm not sure, but
Yeah,
especially
I read
yeah.
the R for data science, but I don't think all these details are there.
Mhm.
I think Pandas
Okay.
is more detailed than
Yeah, more
yeah,
detailed
yeah, I
kind
think.
of a
Yeah, I think.
calculation and manipulation about
Yeah.
dealing with the time series.
Yeah.
Okay, so today's the last one is the shifting the date with the offset. So offset means because pandas date offset also used to the date time or time series offset. So that means if we can importing this kind of a offset function from the day and month end, and then now we have this date and time, and then if we have this day and multiply 3, that actually shows about this one is actually about the 3 days. What is the date and time after the 3 days, which shows about the November 20th, right? And then if we have this kind of anchored option like a month end here, we can actually try to roll forward like a plus sign. And then a month end means the we can get the timestamp of the that last day of the that November month. And then 2 means what is the last day of the 2 months after. So that means if we have a November 17th as a start date, we can also have a 2 months after the end of the last day of the that month is the December 31st. Okay. That's kind of a roll forward. So we can think about the forwarding the dates. And then we can also try to do the backward. So offset is a roll forward now means this kind of a timestamp gonna be doing that. And then a roll back means what is the last day of the before the that start date. Okay. That's the how we can backward calculation of the date and time. And then in here is the more complicated example about the use of the date offset is by using the group by. Maybe, for example, if we have a January 15th as a start date, and then we have a 20 timestamp, and then frequency is the every 4 days, then that actually shows this kind of a time series outcome. And then if we can group by the month end to the roll forward to the mean, that means we can group by the all of the data value based on the end of last day of the month. So this is the one aggregation, and then these are the another group, and then these are the another group, right? If we can think about the month end is gonna be the end date. So based on the that month end, we can actually roll forward. That means we can forwarding from the that start every start date of the each month, we can forwarding this value until to the last day of the month, and then calculating the mean based on this each time each monthly group, and then calculating the mean. That is what this one is about, like a summarizing the time series data set based on the monthly outcome. Okay.
Yeah, sort of a nice way to get some descriptive stats.
Yeah. Very good way to do the descriptive statistic. Very simple function. And also do the same thing, like if we have a resample by using the resample function. Resample function actually allows us to the grouping by to the data set by the n means month.
Yeah,
And then after that we can calculate the mean.
Yeah.
These two are the same calculation, but second option is the much simpler.
Yeah, it's more
But the
straightforward.
thing is, the first one is more like a straightforward, which means it is very clear and easy to understand. And then the second one is the much simpler option about how we can group by aggregate our data set by month and then calculating some specific outcome like a mean, median, or standard deviation, etc. Okay? Yeah, so this is it. And then like we said, chapter 11 is also still very, very long chapter. And then today I'm gonna stop here. Okay?
Yeah.
Then I'm gonna try to do the next week. I'm gonna try to do the start from the 11.4 and then I'll do the rest of them. Okay.
Yeah.
click add box. Okay.